Srijan Kumar Pandey, and I'm going to present my data mining and machine learning project here. So this project needs to be completed in 7 minutes. So I'll just start off showing one result which is very significant and one result which didn't work very well. So the first one is my Caravan Insurance data set where we are trying to predict whether the person will buy a caravan insurance or not. So in this model, I have used two data sets sorry, two models. One is logistic regression and the other one is random forest. So we have the data set here. I'll just go ahead and check. So the random forest, I'm checking with because I've already uploaded it because I just tried to go ahead and do it while I'm on the video and then it's taking so much time. So it is not getting over in 7 minutes. So I already did this. I'll just show uh, with the confusion matrix what is the accuracy we are getting from random forest. So from the random forest, if I go ahead and check, I just check the accuracy here. It's coming 94.3%. That's a good accuracy which we're getting with random forest. Now we just try to go ahead and check this with logistic regression. So here we can see I've started logistic regression, uh, and then I'll go ahead and check. I've found goodness of it and everything here. So first of all, I'll go ahead and check uh, how much is the misclassification. So it's 1 minus the actual. So it's like, I'll just show you. It's coming 0.060. So it's like 6%. So this is the total number of misclassifications we have uh, in logistic regression. All right. So coming next, I have tried the goodness of it here. So I'll just run that. So yeah, this is a good fit because 1.271378 into 10 to the minus 16. So yeah, it's a significant value. Just try to draw uh, uh, RUC curve. So with that, I just wanted to evaluate as well. So uh, this is the package I have installed for ROCR Gplots. Now I'm just trying to show. I think the plot is already there. How I'll just show you how I reached there. Okay. So I'll just click on plots. So this is the ROC curve which I'm getting here. So that's what I'm able to find. It's between sensitivity and 1 minus specificity. And uh, area under curve is obviously it's more than 50%. So when I checked, it was some 63%. And I mentioned that in the report as well. So from this, uh, we got to know that random forest is a better method for this one. And just a moment. Yep. For the second data set, which is the house sale data set, in this, we are trying to predict the price of a house based on the multiple factors like bedroom, bathroom, square feet living, square feet lot, floors, etc. So this is also a huge data set, almost more than 21,000 rows and 22 columns in it. We have uploaded a data set. So in both the data set, we have done one common thing. We check the missing values. The good thing is in both the data set, there were no missing values. Then we tried to upload all these libraries like PLY, CA2s to split between training and test set. So we splitted a data set between training and test. 70% was gone towards uh, training and 30% went towards test. Uh, the, there were so many variables, so I just picked like for this data set, I picked 2, 3, 4, 5, 6 variables. Uh, so similarly for the last one as well, I just handpicked variables because they have 87 variables. Now we did the split in all. I've applied the regression, multiple linear regression here, and with this, I'll just show you the results. So I'll just do the summary of regression. So oh sorry, you'll have to run it just a minute. Okay. think I'll have to start from the beginning. So no worries. I'll just do it one by one so that I get the results. I'll first import the data set, and then I check the missing values. Everything is no missing values. I'll quickly go ahead and run these commands because these are just the basic commands normally pre-processing steps. So I just check the range also for the house prices. So it's between 75,000 to 7 lakh once 77 lakh dollars, and the values are in dollars. So yeah, we'll split data set into training and test. 70% goes towards training, rest goes towards test. Uh, we it shows the correlation with the scatter plot, so it takes time. So I'll not go through it. I'll just run the regression first, and then I'll show the summary of the regression, and then what I've done here is I'll tell you what I've done in next. So this 3 stars shows that it is highly significant. Now this bathrooms and floors, they are not adding any value to it. So in the next one I'll remove it. The multiple R squared, this is the problem here. 0.508, it's very less. And the reason for this is because I've shown in the graph as well. I'll just see if I have the graphs available. So okay, no, I'll just plot the graph. The possible reason for it, because many of the variables, I saw some very strong linear relationship as well between the variables. So I'll just show you. And there are a few which were not normally distributed. So basically, what happens in multiple linear regression, we have some um, assumptions like the variables should be normally distributed. And then, so here, that's the one. I'll just uh, run this and I'll show you. It should be normally distributed. There should be no multicollinearity, no overfitting, no homozygosity, and all these things. So we have to go ahead and so I mentioned everything in the report which I have submitted. So I have verified all the assumptions. So there were few which were not met. So normal distribution we can get through applying logarithmic or square root functions on the variables. So here it is. So yep. So there are few graphs which are good, but there are few which needs to be worked. So sorry, it's taking time. Yeah. So you can see there are few graphs which are good, but yeah, there are few which needs to be worked on. So applying the log or the square root functions will can solve the problem. So yeah, maybe we can go ahead and try to do that. Now what I've done is because all the bathrooms and the floors they were not adding any value, so I'll just remove it and then I run the regression with the values which are highly significant, but still there was no benefit out of it. So here also, if I'll run, so you'll see the same result. It's same, so it doesn't make any difference. I tried to calculate the NOVA for the regression, and this just basically gave me the coefficients and all. Like the good thing is the p-value, it's 2.2 into 10 power minus 16, so it's very less, which means it's highly significant. Rest, what I've done is that I've tried to calculate uh, y predict on the basis of like predicted the test results on the basis of test data, and then I've calculated the VIF as well, because the VIF factor should not be greater than 10. So I tried this as well. So VIF for the three variables which I've taken is 1.52, 1.57, and 1.03. So yeah, it's not more than 10. So yeah, that's fine. But yeah, basically, so one good thing, so in the first data set, random forest, we were able to get better results from it. And then in this one, multiple linear regression, we couldn't get a good result. The R squared value is, I'll just show in the test set, it will go further down. I think it went to 49 something. I'll just show it. No, it's 50. Yep. So that's what the result out of it. So I've done most of the things which I was not able to explain here, so I'll explain in the report as well. But thank you so much. Thank you.